We know how to interpret the slope now, so what about the y-intercept? Well, the y-intercept is 0, comma b. Now, I know that you're thinking, oh, it's just b. That's not true, so don't get into that mindset. It's actually a point, and points on the grid have to have coordinates. When you're talking about where this graph hits, where this line right here would hit that axis. That's what that number right in the back is, okay? So it's not 69 in our example. It's 0, comma 69.108. All right? Oopsie. I pressed the wrong button. There we go. Now, what does it mean? Well, how to interpret it's right here. You say when x, and notice how it's in quotes because it's going to change for every problem. So, for example, in our problem, a school that has 0% of students on free reduced lunch. That's our x, right? I wrote it out in English. And then the y is b. Well, y was the number of students that are, the percent of students that are going to pass, right? The math test. So should expect to have about 69.108%, 8% of students pass the math, state math exam. I don't know why I capitalized that before. I guess I like math a lot. There we go. Notice, by the way, that this doesn't really make any sense. So notice, in some classes it's called being a model breakdown. Because some books call it model breakdown. This book calls it, well, it doesn't really refer to it directly, but because no school would have 0% on free reduced lunch. Even wealthy neighborhoods in America have some people that need free reduced lunch help. All right, so that y-intercept is considered to be outside the scope of the model. That's sort of the phrasing that this author uses. It's not quite the same as model breakdown, but it gets the point across. And the reason that he calls it that is he says, look at the blue dots. Those are your points. So you can go a little bit before and a little bit after. That's called extrapolation. But you don't want to go so far before and so far after that it doesn't make any sense. So that's what I'll write right here. The y-intercept is far removed, right, far away from the actual data we have. So it's not appropriate to make predictions for an x value, or for an x value, i.e. free reduced lunch value, that is that low, right? The lowest we had in our actual data was, I think, 18. I think that's what it was. Let me go back here. Oops, 17. There we go. So that's our lowest value. That's really low, right? Was 17%. But 0% is way far away from that. So we shouldn't be using the line to make predictions for that value. Done. All right. Now, what about Amber High School, which is nearby? It has 40% of students on free reduced lunch. Does the least squares model predict, what does the least squares model predict will be the percent passing that test? So we've got this equation right here. All we're going to do is put 40 in there for x. Simple as that. Let me go type that into Excel. Actually, since I used Excel to do this, I can do it this way. I can use this little cell referencing action, and it's going to be 57.8. And that's all there is to it. Easy as pie.